We're now ready to move on to section 5 of chapter 30. That's Faraday's law, pages 848 through 851 of Knight. So what we've got covered so far is that when we change a magnetic flux, both a magnetic field and a current is induced in the conducting loop. We know that the induced field opposes the change in flux, and the direction of the induced field is determined by Lenz's law. So those are things we've done so far. And then we get our induced current from thinking about the direction of the induced field. So next, let's remember Ohm's law that says V equals I times R. So potential is current times resistance. If we have an induced current happening, then we must also have an induced potential. What's the magnitude of that induced potential? Well, that comes from Faraday's law. We know that we get the induced current from changing the flux, so the induced potential must depend on the flux, and the way it depends on the flux is through Faraday's law. So the magnitude of the induced potential, so the size of the potential, so this is only part of Faraday's law, is equal to the size of the change in magnetic flux with respect to time. Oh, I really have trouble drawing that D. So the size of the change of the flux with respect to time, and this is magnetic flux, of course. But Faraday's law, the full expression, accounts for the fact that the change in field and current has to oppose, no, hang on, that the induced field and current and potential have to oppose the change in magnetic flux. So our induced potential, which has a symbol of epsilon for induced EMF, is minus the change in magnetic flux with respect to time. So that's Faraday's law. And if you want to know how you can get an induced potential, well, we know we have to change the flux. How can we change the flux? Flux is equal to B dot A, or the integral of B dot dA. So you could get a change in flux by changing the magnetic field, changing the area, or changing the relative orientation. And this might be something you can try now with that PhET simulation. As you do any of those things, what do you get for your induced potential? And what do you have to do to get the sign positive? And what do you have to do to get it to be negative? So I'd recommend you try that for a little bit. Then we'll come back and we'll do a few examples.